Welcome to part 2 of writing equations with word problems. Again, this is page 10 in our OneNote, or just the back side of the worksheet. So we're going to keep on going, using all of the same strategies. So hopefully by now you've read number 5, and maybe you're giving it a shot and you're just checking in. So we've read through it, and I can see that the question is, how many hours will it be until the temperature is -20? So again, the main question is how many hours until it gets here. So that's actually part of my end result, is like, this is what I want it to be. That's the end goal. And if we go back into the problem and reread again, we see that the temperature in Frostport is currently 8 degrees. It's dropping at the rate of 3.5 degrees per hour. Okay. So again, we're looking for a number of hours. So I'm going to use H is going to represent number of hours. Here, that's it. It's like not, until it gets to, you could say until -20 if we wanted to get a little bit more specific, but until it reaches that goal. So I'm gonna build my equation up here just because I can't fit it because there's all this space right here. So again, where am I currently starting at? I'm currently at 8 degrees. Dropping means we're decreasing at the rate. So again, we're going at a rate of 3.5 degrees per. Rate means that we're multiplying 3.5 degrees per hour. So per hour. And our end goal is we want to find out at that rate, when will we reach -20? So go ahead and pause the video and go ahead and do your solving and then check back in to see how you did. Okay, how did you do? Right? When you subtract that 8, watch out, don't forget about this negative here and bring that down. Also, if you were to get a negative answer, hopefully a red flag went up, right? It doesn't make sense. We can't have negative time, all right? So just something to think about when you're checking your end rules. And if you need a calculator, by all means, that is A-okay to do that calculation in your calculator, but please make sure you're showing these steps so we know how you reached your final answer. And then restating it in a sentence, after 8 hours, the temperature will be -20 degrees Fahrenheit. I believe it's, yep, Fahrenheit. All right, let's go on to the next one. Same thing here. I'm going to do most of my work up in this blank space just because that's what fits on my screen. All right, so we've read through the problem. You're going to pause, just read through the problem, do your highlighting. Okay, and we can see here that after reading that, we see that it says, how much does her father weigh? How much does her father weigh? Okay, and we're going to go through and it says, Jennifer weighs 99 pounds. That's what she weighs. Her weight is, okay, her weight is 5 pounds less than 2/3 of her father's weight. Okay, like I highlighted that whole sentence. So this is more like, this is like riddly looking. All right, so let's kind of take a look. It says, how much does her father weigh? So I'm just going to go ahead and I'm going to use F for father's weight. All right, and then let's go ahead and take a look at what we know. We know Jennifer, so if she weighs 99. Her weight is, whose weight? Jennifer's weight. So Jennifer's weight, if we write this out in words, is 5 pounds less than. Well, if I have 5 less than you, means I have to take whatever yours is and subtract 5. This is one of those turnaround phrases. So this really means -5. 2/3 of, anytime you got fractions, 2/3 of means we're going to multiply. So we're going to take 2/3 of her father's weight, 2/3 of dad, and then we're going to take 5 away from that because it's 5 pounds less than whatever that is. So now if we've mapped it out in words, let's put that together with all of the numbers. So 99 was Jennifer's weight, and we're going to do 2/3 of her father's weight. Well, we don't know what her father's weight is, so there's our variable. But then we're going to go ahead and do 5 pounds less than that. So again, this was riddly, and so we want to make sure that, we just don't throw all these numbers together without making sense of them. So if we need to write it out in words and come up with a game plan, by all means, that is a great strategy. All right, pause and solve. Okay, how did you do? So something to think about. Let's say that you're solving and maybe you got, oh, I don't know. Let's see what might have happened there. Let's say you got 68 pounds or like 69.3333 repeating, right? You can have part of a pound and everything, and decimals or fractions are okay by this, right? But remember, Jennifer, like her father weighs more than her. She already weighs less than, part of what he weighs. So again, if we got something that was less than Jennifer, we have to kind of think, does that make sense? So we always want to check to see the final answer that we get, does it make sense? Because sometimes here with the fraction, we forget to multiply by the reciprocal, and perhaps you multiplied by 2/3 instead of 3/2. So when we put that sentence together, her father weighs 156 pounds. We want to make sure, does that make sense? All right. These next two problems, all right, I'm going to do number 7 with you and kind of work it out. And then what I want you to do, number 7 and 8 are very, very similar in their setup. So all of these problems that we have been doing have been just kind of like looking for one thing and not really comparing these two different situations. So pause for a second and read through number 7. All right, so hopefully you've read through problem 7, and we can see here that there's actually 2 different questions. So we want to know, after how many years would Janine's salary be the same with both companies? So essentially, after how many years will both companies give her the same amount of money? Okay, and then what would that salary be? So we have 2 questions that we need to find. Let me do that one in blue since it's a separate question. I got to make sure I come back and answer that. All right, so let's take a look at the facts. What do we know? So she's got some job offers at 2 companies. The first company, let's call that one, I'm going to say that's company A. All right, the first company offers a starting salary. You're going to start with $28,000, and she gets a raise of $3,000 each year she's there. Okay. And let's do in another color, company B. The other company has a starting salary of $36,000 with a raise of, again, we probably should have highlighted raise, $2,000 each year. And we will call this one company B. All right, well, the first thing that we're trying to find is, after how many years will they be the same? So I'm actually, before I even jump down into my variable here, I'm going to take a look at this. So kind of trying to squeeze this in here. If I'm going to write my equation, before I even get to an equation, I'm going to write an expression to represent company A and company B. So company A, she's going to get $28,000 plus $3,000 for every year she's there. So we're going to use Y to represent the number of years she's at that company. Well, then we have company B, and they offer her, you know what, we'll give you $36,000 to start, but we can only give you $2,000 every year for raise. So those 2 are separate equations for them. But the question is asking, when will they be the same? So when will company A's offer be the same as company B's offer? So this variable does still represent years, but more specifically, the Y now represents number of years when both companies are equal or the same. Okay, so when we're solving for that, we have to understand that, yes, it is number of years, but it's more specific than that. It's when both companies will be paying her the same amount of money. All right, so now we have this equation, 28,000 plus 3,000y equals 36,000 plus 2,000y. All right, so now we can go ahead and start solving. So again, great time to pause the video and work it out. Okay, so here's the final solution. But again, we had 2 questions that we had to answer. So right now we have the first part. We have part A's answer. So after 8 years, both companies will be the same. Okay, so after 8 years, both companies will be the same. Now, what will that amount be? Well, again, we just solved for y, right? And so if we take this answer here, we know that after 8 years, we're like, okay, well, after 8 years, how much will they be getting? So what we need to do is we need to then take this information and we need to insert it back in. Now, we're not inserting it back into the equation. We're actually just inserting it into the expression, because what happens is this is company A, 28,000 that she starts with, and it's 3,000 for every year. So that's after 8 years. So we get 28,000 plus 24,000, and we get $52,000 at company A. Well, we can do the same thing for company B, but it's not necessary because, again, remember, after 8 years, they're both going to be the same. So we should hope that we should get the same answer. Well, here's company B. Let's just check our math, and this is a great way to check to see if we did our solving correctly. If I plug it in, I'm supposed to get equal value. So I get 36,000 plus 16,000, and I get $52,000. So after 8 years of working with both companies, Janine will be earning $52,000. So the second question depended on our first answer. So we had to set them equal to each other and then use that answer to fill it in. Again, we did not need to fill it into both because our answer by definition about what our variable was represented when they will be the same. So as long as you plug it back into one, you'll be set. So for number 8, it's the same idea. So I'm going to encourage you to go ahead and pause the video and go through that setup. And then check back in when you're ready to check the whole thing. Okay, so here's the key information that I highlighted. We've got 2 questions. When will they be the same? And what will that temperature be when they are the same? So the first thing is that here, let's just check in to see how you did with the setting it up. All right, so H is going to stand for the hours that when they'll be the same. And so my goal was, when will Cold Mountain equal Frost Valley? So I wrote an expression to represent the temperature at Cold Mountain. It's at -5 and increasing 2 degrees every hour. But Frost Valley is 19 and decreasing. That's why it's -4 per hour. So here's that setup. So if that's where you're at, great job. If you need some time to catch up, okay, just pause and finish solving and make any corrections that you need to. Okay, and here is the final steps for finishing this up. So we solved and we got H equals 4. And remember, H stood for the number of hours when they're the same. So after 4 hours, Cold Mountain will be the same as Frost Valley as far as temperature. So then I had to take that information and I had to plug it in to the original expression and figure out what that temperature was going to be. So now I didn't have to do it for both of them, but I did just to double check to make sure I was supposed to get the same answer. So after 4 hours, both places will be 3 degrees Fahrenheit. Let me know if you have any clarifying questions,